Hello my fellow chemicals. In this video I'm going to be doing something a little bit more safer and kid friendly. And I really wanted to do this experiment and film it because it's such a simple way to make an endothermic reaction. Now you may be asking, well, what's an endothermic reaction? Well, there's two types of reactions, endothermic and exothermic. Exothermic is when a reaction releases a lot of heat, like fire. And endothermic is when a reaction absorbs heat, so it gets cold. And endothermic reactions are a little bit more rare than exothermic reactions. And this is a very basic one. All you need is citric acid, which you buy at your shopping store as what is it? It looks like this in my country. Just citric acid, and it's really cheap. It's used for preservatives and flavorings. And the second chemical you need is sodium bicarb, baking soda, not to be mixed with baking powder. Do not use baking powder, it's baking soda. All you need to do is mix these two chemicals together. Yeah, I've mixed them in this round bottom flask. You don't need something that's fancy. You can use styrofoam cups if you want. And a little extra chemistry thing is that the citric acid you buy is normally monohydrate, which means it has one H2O molecule or one water molecule attached to it. So what does that mean? It means that in order to kind of get this reaction going, you add a bit of water. And since the citric acid contains a bit of water, it should be reacting right now in this flask. In fact, the stopper just blew off here because of the pressure buildup inside. Now you may be asking, well, what's building up the pressure? Well, you see here in the balanced chemical reaction, we got citric acid reacts with baking soda to form water, CO2 gas, and trisodium citrate. Now this is pretty safe. It's also known as sodium citrate. Don't have to worry about that. And the CO2, we can prove that now by lighting a stick and putting it in there, and you'll see the flame which should turn out. Let's try that. Okay. Here's the burning stick, and now I'll put it inside the flask. As you can see, it immediately turns out. It dies down. I'll try that again. Try to get a good piece of it. There we go. Burning stick. I put it in and immediately turns out. As you can see, it's reacting inside the flask right now. Now, to speed up this reaction, right. So now I've demonstrated that there's CO2 building up inside it. Now you can possibly, if you want, design a tube adapter, like, hold on, like this thing here, where this kind of fits, and you would lead this tube, I don't know, into your plant, if you have like a small growing area. And in theory, the moisture in the air could also help with this reaction go faster, but the monohydrate in the citrate is doing quite a lot of work, as you can see. Not sure the moisture in the air right now, or the humidity, but the higher the humidity, the faster reaction will go, and you can lead the CO2 to do what you want with it. Right now, the main part is to demonstrate an exothermic reaction. So a good idea to start is to measure the temperature of the water. And the temperature of the water is going to be around 18 degrees. This should go down. I don't want to wait that long. And then what you do is you pour the water in here. Well, this is a mixture of the baking soda and CO2, and baking soda and the citric acid, sorry. And there'll be a lot of bubbling that happens. And the bubbling will be the CO2 gas, as we demonstrated. And since the reaction is endothermic, it will start absorbing energy and get really cold. Let's begin by pouring in the water, and you can see the bubbling happen when I pour it in. Try pour it in slowly and not all at once. There's a chance this might overflow since I don't like a lot of bubbling liquids, especially in a flask like this where it could burst like a volcano if you pour the water in at once. I can add a bit more water. Can give it a quick stir, and you can see on the thermometer that it's already at 10 degrees Celsius, and this should get colder. I'll add the last bit of water. The measurements of the liquids does not have to be precise. You can just use teaspoons and tablespoons. If you want to do it with stoichiometry, which is measuring chemicals exactly to how much would react with what, it would be, as you'll see, if you need 3 moles of sodium bicarbonate to 1 mole of citric acid. But again, you don't have to make this you don't have to be precise with any of the measurements. I just threw in randomly. The temperature is now at around, let's see if I can get that on camera. There it is. It's around 6 degrees Celsius. Another way you can test it is take this lighter, yeah, and then you bring the flame to the top, and you see it goes out. CO2 gas. And that's the reaction. Do the swirl it a bit, and the temperature is really cold. It's actually quite cold. If you can touch it, and it's really cold. It is now going to be at around 5 degrees, and it should go to around 4 degrees Celsius the longer you leave it. And maybe, yeah. So it's around 5 degrees Celsius, and then it should get a little bit colder than that, but not much. And that's the reaction. Thank you for watching. Please like and subscribe.